Okay, so in this video I will try to see if we can do a better job to define the cytoplasm area using the cell module in Imaris. So currently this is what we did previously, and while the result is okay, it doesn't include the fine filaments here that you can see in red. So let me just get rid of the cell module here, and if we look here at the image in the red channel, we can see those filaments that should be included as part of the cytoplasm. So let's try to see what we can do to enhance our detection here. So I will start by, first of all, try to refine my data set first, because if we have a look here in the edit menu and image properties, we can see here that we have only 7 slices in the Z direction. So what we can do is go here in the edit menu and resample 3D to change this number here. So we keep the same aspect ratio here, but let's say we change this number to 30 here. This will give us a bit of leeway when we do some processing further down the line. Okay, so as you can see here, nothing has changed, but if we now proceed with adding a new cell, we will get much better results. But before we do that, let me just discuss a bit the choice we have to make here. So previously on the other video, we used this channel to create the cytoplasm part of the cell. Here, since it's quite pointillistic and we are interested in fine details, we cannot use the same approach as before. So let me just show you what I mean. If we proceed with the creation of the cell object here, so first of all, let me just quickly go through the nuclei part as we did before. So let's use something like 5 microns, sorry. We want to split the nuclei by seed points. Here we want to include more of them, and we want to exclude those who are close to the border, distance to image border like this. So we are left with the 2 nuclei that are interesting to us. Now this is the volume for the nuclei. So here I like to switch to volume display, just because, let me just show you quickly. Here, if I play with the threshold, and let's say here I think it's not touching, let me just get a bit closer like this. So those will be separate objects. Actually, it's not the case. That's because if we switch to volume, now you can see that they are indeed touching, but maybe not at the same plane we were at. So if I move to a different plane, maybe we can see it, yeah, here. At some point. It was touching here. So anyway, that's why I usually use volume display to get a better preview. So now we should have our 2 nuclei, and we can already see here that the definition of of the shape is a bit better since we are now using 30 slices instead of just 7, and we will get a similar improvement using the other channel for the cytoplasm. So let's move on. So here we want to get rid of the nuclei for a moment here. So go just to settings and check nucleus here, and now we will proceed to the detection part. So if I use the green channel here, I have several options here. So smoothing and background subtraction. I probably cannot use background subtraction here too much because it will increase the contrast between the bright parts and the dark parts. So the signal will be more contrasty, and we will get into trouble here. Let me show you what I mean. So if I use a minimal value, let's say 0.05 for filter, if I go to the next part, now we can see quite a lot of detail here. But the problem here we can see is that if you want to include the filaments here, they are not well defined by this signal. So either we have to include too much or too less. So what can we do? Well, maybe if we go back, we can increase the smoothing factor. Let's use 0.2 for instance. So it looks a bit better, I would say. But we cannot discriminate too much here. So another option would be to use the other channel, so the red one. So let me quickly switch here. So with the red channel, here the problem we have is that we have a very well defined filaments here, but now the central part of the cells is looking very hollow. So if we smooth the signal as before and proceed here, we can be a bit more restrictive, but then we'll start to see holes inside our cells. So what we can do at this point is maybe try to do some post-processing on our image to even a bit this signal. So let's just leave the cell module for a moment, and here what I will do is duplicate this channel so we can get a comparison. So in order to duplicate this channel, there is no easy part, easy way to do it. The small trick I can give you is to use here add new surface, and what we want to do here, we don't want to classify, etc. Just want to create quickly one surface of the channel 3. We don't want to smooth it whatsoever, and we want to include, maybe you want to smooth it a bit because it's really looking a bit too noisy to my taste. So just slightly 0.1 should do the trick. Yeah, something like this. So everything you see here will be part of the new duplicate channel. So clearly here there is nothing. So it's fine for me. So let's go on with this. And now with this newly made region, let me just finish the result here. If we go to the Edit tab here, we can choose mask all. And when we do this, you can create a mask. So let's use the red channel, and here you can see duplicate channel before applying mask. And this is a small way to quickly duplicate a channel and also clean up a bit your image, because everything outside the surface here will be set to 0. So let's just do this quickly. So now we can safely delete this surface, it's not needed anymore. But now we have actually two channels. We have the original red channel and the duplicate red channel. It's just that into this region there is nothing anymore. While here, I don't know if I can play a bit with the output here. Yeah, you can still see something here. But now, in this channel, there is just nothing. Anyway, so let's use this duplicate channel here to do our processing. So in order to do that, we go to image processing here. And here now we make sure we are on the right channel, and we will add some filters. So to even a bit the signal, we will use a Gaussian filter. So we can already see the preview here. Let's say 0.2. It's looking fine. Maybe 0.3. Yeah, something like this. Then we can add another filter. Let's say we want to add some gamma correction just to lift a bit the signal. Not too much, but just a tad, like this. And maybe clean up the darker areas here. So in order to do that, we can do some background subtraction. So if you want the effect to be a bit less intense, you have to actually increase the value here of the filter size. So for instance, if you use 20 microns, it's a bit better. Let's say 50. It's almost like there was no filter, but here it's now quite clean. Once we're satisfied, we can press OK. And now we have a cleaner and simpler signal. So if we compare this to the original image here, we still have mainly the filaments here, but it will be easier for us to segment the image with the cell module. So let's go back to the cell module here and recompute. So we want to use here just nuclei in cytoplasm. Here we can leave the parameters we had for the nuclei, because it was already okay. They are not seen here because I have unchecked this. So again, volume display is a bit better. So now we have our two nuclei, and now we will use the red channel, the modified red channel, so the masked one here. We do not need to smooth it, that has already been done. Again, background subtraction as well. So you can just proceed here and choose wisely the threshold to include this time all the filaments that are needed here. Okay. And we want to split the touching cells with distance from nucleus. Let's continue. So calculation takes a bit longer since we have now more Z slices here, and here just want to get rid of the small objects, so I'll just decrease here the number of objects selected. We end up with those two here, and we can finish. So this is now the end result with a much better cytoplasm detection if we compare it to the previous result here. So this is with our small processing, and this is before, so much more simplistic. And you can especially see here the scale effect due to the only 7 slices we had in the Z direction, while here we have a much more precise result. Okay, see you in the next video. Bye bye.